Okay, hi everybody. So, before moving forward in this course, I was thinking to prove those uh, six important formulas that I have left in the previous video. Okay, uh, so this is a bonus video in some sense, where I am going to prove all of six formulas. Okay, it is going to be a long derivation, and if you don't want to know how to prove these formulas, or if it is not relevant to you to your course, then you can always skip this bonus videos. Okay, and apart from that, I am also going to, first of all, I am going to prove the linearity properties of all three operations. Okay, so the curl, divergence, and this the first one is the gradient operation, how they are linear. I am going to prove this. Okay, so first of all, what I am going to do is to prove the linearity of del operator. Okay, so first of all, take this del operation a f plus b g. Okay, so this a and b belongs to some real numbers, so this a and b is a scalar, is a constant actually, right? F and g are the function of x, y, and g. Okay, and they are the scalar quantity. So this del can be expanded as del by del x. Okay, x cap del by del y, y cap. So I'm writing, I'm expanding only for this. Okay, let me. Okay, I will write for the whole three component. This a of f, b of g. So what we can write: a of f, b, g, x cap del of y, a of f, b or g, plus del of y. This is z cap, a of f plus b of g, and z cap will be there. I left this y cap over there. Okay, after that, so this is just a derivative. So what we can write like this: del by del x f x cap plus b del by del x g x cap. In the similar way, we can write del by this is the a y f y cap plus b del by del y g no this is yeah, y cap plus del by del y a, this is f and z cap, plus b del by del y. No, this is not y, this is actually z, so I made a mistake over here. This is z. Okay, so a f z cap plus b del of del z g and z cap. Okay, so instead of this y, it will be z. So 1 2 3 4 5 6 term together. 1 2 3 4 5 6. Okay, now taking this x cap, okay, this y cap and this z cap, all of three have this f and a as a coefficient. So a del by del f x cap plus a del f by del x y cap plus b del f by del x z cap. In the similar way, we can write this term, and this term. We have same thing over there. Okay, this b del g by del x cap. Now this is plus b del g by del y cap, and over here we have b del g by del z over z cap. Okay, so common out this this is going to be a term. Okay, so this is actually that term. Yeah. I think this is del f by del y, and this is del f by del z. Okay, so this term is actually this term, and this term is actually this term. Yeah. So okay, factor out this a and this del by del x, del by del y cap from this term, and del by del z cap. So we have factored out the a and the f. In the similar way, we will factor out b and del by del x cap from this term, from del by del y cap plus del by del z cap, and then g will be factored out. Now we know that this is a del operator acting on f and multiplied by a, and similarly b multiplied by del operator acting on g. So we have proved it, del of a times f plus b times g. Okay, so this proves that this gradient is gradient is a linear property, linear operator. Okay.